talking about chi-square test for homogeneity. Before talking about homogeneity, let's talk about goodness of fit and test of independence. Goodness of fit, we used to use that test to decide whether a population fits the given distribution or not. And in test of independence, we try to see if two different variables are independent or dependent. Similarly, by the word homogeneous, we will try to check or test whether two variables have same distribution or not. Test of homogeneity can be used to draw a conclusion about whether two populations have same distribution or not. We always need to realize that the observed value is already given. We try to come up with expected values. Okay, we get a separate different table for expected values, and each cell needs to be at least 5 to use this test. Okay. Hypothesis, the null hypothesis and alternative hypothesis follows this kind of statement. Okay, the distribution of the two populations are same, that's null hypothesis, and distributions of two populations are not the same or they are different. Okay, so keep this in mind, and we again use the chi-square test. Okay, and it is computed in the same way as the test for independence. And degrees of freedom, of course, that's the number of columns. Okay, so slightly different than test for independence. Okay, so here common uses: comparing two population examples, men versus women, before versus after, east versus west, and so on. The variable is categorical with more than 2 possible response values. And again, the same kind of thing, I would ask you to go through this document. This will help you a lot. Now let us go for one example, which is somewhere over here. So let me take this example, try it, 11.8. Do families and singles, so let me just head over here. Do families and singles have the same distribution of cars? Suppose that 100 randomly selected families and 200 randomly selected singles were asked what type of car they drove: sport, sedan, hatchback, truck, van, SUV. The observed values are given. The results are shown in the table below. Do families and single have the same distribution of cars? Use a level of significance of 0.05. Okay, so now here you can clearly realize that it is saying that 100 randomly selected families and 200 randomly selected singles. So this would be 100, right? And this is 200, so this would be 300, right? Okay, so there's the calculation. And now let us go for null hypothesis and alternate hypothesis. Null hypothesis: family and singles have the same distribution of cars. Okay, same distribution. Family and singles do not have the same distribution of cars. Okay. Number 2, we go for chi-square test of homogeneity. Alpha, the significance level 95% or 0.05, right? And okay, test statistics, p-value, right? Okay, we need to find these things. Okay, and before that, we know how we will be getting the expected values, right? It's just like test of independence. So what we do is we multiply this value 100 times 50 divided by 300 in this cell. Similarly, 100 times 80 divided by 300 will be in this point in this cell, and so on. You do that again and again and again. 200 times 50 divided by 300 will be here. 200 times 80 divided by 300 will be here, and so on. Okay, so that's how we get the expected value table. Okay, now we won't be going through all of the calculations since we already know that. I'll be just inputting all these values. Okay, just these observed values in the GeoGebra probability calculator. Okay, go to statistics and then go for chi-square test. Rows, we just need 2 rows, we need 5 columns. Okay, so 5 columns and 2 rows. Okay, so this is of course family. Okay, so I have written down all the data including the headers of the rows and columns. Okay, so sport, sedan, hatchback, truck, SUV, family versus single. Okay, all the things are given over here. To get the expected table, tick mark this one, expected count. So we get all of these things: 16.667 for sport, for family, 33.33 for single. Okay, now degrees of freedom is of course 4 since there are 5 columns, right? Chi-square is the test statistics is simply the observed values minus the expected values divided by the expected values. and we add them all up, and the p-value is 0. The test statistics is chi-square is 62.91 and the p-value is 0.00. Now then, if we compare these two, then we definitely know that alpha is greater than p-value, okay, since alpha is 0.05, which is 5%, and p-value is 0.00. So since alpha is greater than p, reject the null hypothesis. That means the distribution are not the same. Okay, so in conclusion, what we write down is number 3. Conclusion, for 5% significance level, there is sufficient evidence that distribution of cars for family and single are not the same. Okay, so that's it. That's how we go for test of homogeneity. And before doing any problem of homogeneity, many of you might be concerned about how to figure out whether we should go for goodness of fit or test of independence or test of homogeneity. So I would ask you to go for this 11.5 comparison of the chi-square tests, and then go through these 3 paragraphs, and you will have an idea about when to use goodness of fit or test of independence or test of homogeneity. So let me just go through this quickly. Goodness of fit is used to decide whether a population with unknown distribution fits a given known distribution or not. In this case, there will be a single qualitative survey question or single outcome of an experiment for the single population. Okay, so there will always be single population. Okay, that means it won't have it will have contingency table, but the contingency table will have only one variable, and then we need to realize whether we need to go for whether the distribution fits one kind of distribution or not. Okay. The null and alternative hypothesis would be the population fits the given distribution, the population does not fit the given distribution. That's straightforward. And always, what is the known and unknown distribution? Unknown distribution, we do not know it. Known distribution, it could be population will be normal, or it could be uniform distribution, or say a binomial distribution, a proportion distribution, or students t distribution, or something. Okay. If you go for test of independence, we try to realize whether 2 variables are independent or dependent. And the null and alternative hypothesis are 2 variables are independent, that's null hypothesis. Alternative hypothesis, 2 variables are dependent. Homogeneity, we test whether 2 variables, okay, 2 populations have same distribution or not. Null hypothesis is 2 populations follow the same distribution. Alternative hypothesis, 2 populations have different distributions. Okay, so that's all for how to choose distributions.